Okay, 3-3 notes here, and we're talking about properties of logarithms. So we kind of learned about those in 3-2, what they were, and some different um, uses of them and different properties there. We have a few more as well. So if you remember from back from Algebra 1, okay, when we had uh, this a long time ago for you guys, but back in Algebra 1, we had these exponent rules, the rules of exponents, when we had the product property where you added exponents here. If they were dividing, if there was quotient, then you subtracted exponents. And then if it was a power to a power, we called it the power property here where you multiplied the exponents. So the big focus here is that because these guys are inverse functions, remember we talked about that before, because they're inverse functions, then these properties of exponents imply the corresponding properties of logarithms. So they're similar, they're not exactly the same, but they're similar. So here are some of those properties. Okay, so you have the product property right here. So this one, they're named the same, right? Product, quotient, and power property, but they're a little bit different in how they are. So if you have a product with a logarithm, and again, x and y are positives, and b is not equal to 1, then, and if p is a real number, right? So then all of these are true. So the first one, the product property. So if you have a product of logarithms, then you can, with the same base, then you can add those up. Okay, you could split them up with an addition sign right here. Log base x plus log base y is the xy. Same thing with the quotient. So those are very similar to the other ones. So you have right here, you've got log base b x divided by y, so you can subtract those as long as they're the same base, log base x and log base y. Okay, now here's where you have the power property, slightly different, but you'll get used to it. So you have log base b of x to the p power. You basically just take that p and you can write it out in front. So you take it in front. So now the p goes, instead of the power becomes multiplier in front. It goes p log of x there. Okay, so make sure you write those down, pause, rewind, do what you need to do, and then we'll kind of look at these. Okay, so here's some practice problems. First one, you're going to look at writing them in terms of logs 2 and 3. So you got to have both of these 2 and 3. So what I'm trying to do is I'm going to take this log of 96 here in the first one, and I want to write it in terms of 2 and 3. So I'm looking to split this 96 into a, kind of a multiplication, split it up where we use 2's and 3's and powers of 2's and 3's. So you might have to do some guess and check here and some work here, but if you take 96 and divide it by 3, so that's what I would start with one of these and like divide it by one of them. Because then if you get a power of the other one, then you're in business. So I guess the easiest way to look at it is if I take 96 and I divide it by 3 here, and I could do it either one, I could divide by 2 or 3, but 3 seems to work here. What I end up getting is 32. Well, that is nice because that's 2 to the 5th power. Now I can write it in terms of 2 and 3 because I could say log of 96 then equals to log of 2 to the 5th power, because that was 32, times 3. Now, sometimes you need to do a power for both of them. There might be an exponent that you need on 3 and 2, but it's just going to have to play with it a little bit to get those. So now, because of that, I can go ahead and I can look at the product property up here. Because they're multiplied, I can split them up and add them. And I can say log of 2 to the 5th power plus log 3. Okay, so I'm good so far, but now I can go one step further because of right here, I've got the first term, I have a power property because I have 2 to the 5th power, so I can rewrite that as bring that 5 down here, 5 log 2 plus log 3. And that would be my final answer there. Okay, how about this one? Well, this is already in quotient property. You see the quotient property, it's already in a division problem. So I can rewrite this log of 32 minus the log of 9. So again, I'm trying to get it between in terms of 2 and 3. So I've got to write these. Now, luckily for us, those are nice, and they're definitely exponents, powers of 2 and 3. So 32 is, we just did this in the last problem, 2 to the 5th power. Oh, what the heck? Okay, awesome. I don't know what the heck that was. All right, so 2 to the 5th power, and then log of 9, we know 9 is 3 to the 2nd power. So these numbers may change, 2 and 3, but right now that's what we're kind of looking for. All right, now I can use the power property and bring this 5 down in front and have it 5 log 2 minus, and same thing here, I can bring that 2 out front, 2 log 3 by using the power property as well. Okay. So now we're going to continue on, and this next couple examples are just evaluating these two. Evaluate each logarithm. It doesn't have you at a certain term. So now we're trying to just kind of see if we can kind of evaluate this into a different term, kind of simplify it. So in this case, again, using the idea that I can break that 32 because of log of 2 right here, I can break that into a power of 2 for 32. So if I do that, I can say log base 2, okay, equals, well, first I'm going to take this cube and write that as a power. So equals 32 to the 1/3 power, because square roots would be to 1/2, so cube roots are to 1/3. And then what I'm going to do is I'm going to change that 32 into a base of 2. So I go log base 2 equals 2 to the 5th power, and that goes to the 1/3 power. All right, so my exponent rules in exponent form, which this is kind of exponential form over here, tell me I can multiply 5 times the 1/3. So I've got log base 2 I guess you need that equal sign there. And then 2 to the 5/3 power. Okay, now if you remember from, well, I'll go one step further and then we'll kind of talk about it. But now the power property says I can move this power down in front of it. So I would say 5/3 log base 2 of 2. So if you remember from section 3.2, whenever you have, say, these log with the same base of, log base 2, these two numbers are the same, that basically equals 1. So my final answer here then would be 5/3, because it would be 5/3 times 1. Okay. All right, let's look at the next one. So right out the gate, I'm going to use the power property, but I'm just going to do it on this part here and here. So I'm going to start out with 3 times, use the power property, bring that 4 down, natural log of E, minus 2 times 2 natural log of E, because that's a power property from above, move that exponent down in front. Now I can actually do the multiplication. I guess I could do that all at once if I wanted to, but so now I have 12 times natural log E, and then minus 4 natural log of E. All right, so now because they're the same, I can go ahead and subtract them. 12 minus 4 gives me 8 Okay. And now, if you remember again from yesterday or whatever it was, section 3.2, natural log of E is also equal to 1. So you basically have 8 times 1 or 8. So those worked out nicely for us. All right, next page. So properties of logarithms, these provide a way of expressing, we're just reading it to you, logarithmic expressions and forms that use simpler operations. So kind of converting them into addition, subtraction, multiplication, and powers and roots into multiplication. So we take that multiplication, you make it into addition, division, subtraction. You take the powers and roots and try to make them into multiplication. So here we're going to kind of expand these into a longer form and take all these all the multiplication here. There's multiplication here and here. These are going to turn it into addition, subtraction, and division. And then the powers and roots here that you see, we're going to try to make those into multiplication. Just going to expand this out. All right, so let's first look at this and see that what we're seeing here is a product. You've got natural log of 4, and we've got times m cubed. We kind of mentioned that before. You got a lot of products going on. Times n to the 5th. So if I can expand that, since it's a multiplication there, I could expand this out and say it's natural log of 4 plus the natural logarithm of m cubed plus the natural logarithm of n to the 5th. Okay, so now I just expanded that out and made all these multiplication, okay, using the product property. Now I can use the power property because I've got this 3 and this 5 here, and I can move those. The first term stays the same. Second term now becomes this. And the third term, I'm going to bring that 5 in front and becomes this. And that's as far as we can go. So we've done it. Okay. All right, next. This one here, we look at taking, so because it's, again, a quotient right here, I can already put it into subtraction form. So I can say log of 2x minus 3 subtract the log of 3 to the 4th root of x. Okay. All right, so I'm going to rewrite this. The second term, basically, the first term is going to stay the same, but I'm going to rewrite the second term, changing that 4th root into a power. I'll put that in parentheses and say 3 times x to the 1/4 power, because it's a 4th root. All right, now, again, the first term, nothing different has happened here. The second term, though, I'm kind of distributing here almost. I'm just kind of taking this minus the log and saying times 3x, or times the 3 part, sorry, log 3. And then it's going to be plus the log of x to the 1/4, right? Now, finally here, again, first term, nothing changes, so I put that there. The next two terms now, the only thing that's going to change here is that, I guess this should be a negative, right? And then you've got, I'm going to take that power and put it in there. It should be a negative log, positive. So then it's going to be 1/4 log x. And there you go. So we've expanded that out into multiplication or division, from division into subtraction. Take the powers into multiplication. Okay. Oh, shoot. I think I had covered up some extra problems. All right, so we're going to talk about condensing them. All right, here they are. So condensing them, if we take a look at that, we're kind of going the other way. We're going to try to make it a little bit more condensed. So kind of reverse this and take it back from subtraction into division or multiplication. All right, so here what we see is, first thing I'm going to do is I'm going to kind of go backwards, go the other direction. So in this case, I'm going to take this and I'm going to write the 1/2 as a power to this, because so then I'm going to have log base 4 x minus 3 to the 1/2 power. So I'm just going in reverse from what we did in the previous examples here. And then I'm going to take this 3 and move it up here as well. And so it'll end up being minus log base 4 x minus 2 to the 3rd power. All right. Now, again, just working backwards. So what is something to the 1/2 power? It is a square root of, right? So I'm going to take log base 4 square root of x minus 3. Remember, I'm working backwards. I'm condensing now. So I'm going back into multiplication and division here. And then from here, this would be the cubed root, right? So it would be, oh no, it wouldn't be the cubed root because it's not a fraction. So I can keep that the same. Log base 4 x minus 2 to the 3rd power. Now, because it's a subtraction problem, I can put that as division under 1 log base 4 with this on the top, square root of x minus 3, and on the bottom, x minus 2 to the 3rd power. Okay, so I have a quotient now from the subtraction. Here I have addition, so I'm going to probably condense this into multiplication. So this one will go a little quicker. So the first thing I can do is I can say, all right, I'm going to move that 5 up here, and I'm going to move this 6 up here to the exponent. So it would be natural logarithm of x plus 1 to the 5th power plus natural logarithm of x to the 6th power. And now, because it's an addition, I can go ahead and they're both natural logs. So I can say natural logarithm x to the 6th times x plus 1 to the 5th power. And that's as far as I can go, but I've put them as a product. Okay? All right, last thing, and these will go a little bit quicker, but change of base formula. So anytime you have a positive real number, a, b, and x and all that, a and b aren't 1, this formula will hold true. So again, draw this if you need to. Write it down. Log base b of x equals log of a of x over log of a of b. All right. So again, most calculators only have a 2 keys: log, this one here, and then natural log as well. So either one of these fit. So with the change of base formula, you can use either method. You can use the log where you divide it, or you can use the natural logarithm and it'll still work. Okay. So we have log b of x. And so all we're doing here is changing the base of this formula. So these will go pretty quick. So if you think about it, if you have log, this would be your b, this would be your x. So if I go log x over log b, so log 6 of 4, log base 6 of 4 would be, if I took this, went log of 4 over log of 6, and I just punch those in my calculator. Either one here, log or natural logarithm, will give you an answer of about 0.77. Same thing over here. Again, this is my b value, this is my x value. So again, using either one of these, if I take log base 1/3 of 8, if I go log of 8 over log of 1/3. Or if I do natural log, it doesn't matter. I'll get negative 1.89, and that would be my final answer there. Okay, so covered a lot of stuff. If you have questions, bring them in. Just over 20. I was hoping to keep it shorter. I failed on that one, but oh well. A lot of stuff done in 20 minutes. Bring your questions as we go.